Hello and welcome to another exciting math video. This video will continue section 2.5. This is the day 2 material. We're going to start out with a little warm-up. We're going to FOIL this out. We've got a 2 plus 3i and a 2 minus 3i. Notice this is a sum and a difference of the same two terms. So when we're foiling, the outers would be a negative 6i and the inners would be a plus 6i, so those are going to cancel. So when we FOIL this out, all we have to do is first term times first term. 2 times 2 is 4. Positive times a negative will be a negative. 3i times 3i is 9i squared. And remember, I squared, the definition of I is the root of negative 1. So this I squared is going to turn into a negative 1. And when we multiply this, negative 9 by negative 1, it just changes that to a plus. So the I squared disappears, and this changes to a plus. So our answer there is 4 plus 9, 13. I have a feeling we might need that skill in the upcoming lesson. All right, now example 5, find all real solutions of this mess. Let's see, it's in descending order. Let's figure out our possible rational zeros. So we're going to make our fraction. The numerator will be the factors of 12. Well, let's see, 1 times 12 is 12, so 1 plus or minus and plus or minus 12 are in there. 2 and 6, 2 times 6 is 12, both again positive and negative. And then 3 and 4. 3 times 4 is 12. So there's all our possible numerator values. Our denominator here is a 10, so that'll be plus minus 1. 1 times 10 is 10. 2 times 5 is 10, and that's it. But it looks like we're going to have a lot of possibilities. Starting with the numerator 1, we'll have 1 over 1, and then 1 over 2, and then 1 over 5, and 1 over 10. All of these are positive and negative, so we already have 8 possibilities. Let's look at the next one here. 2 is in the numerator, so 2 over 1 is 2. Now here we're going to get a repeater. 2 divided by 2 is 1. We already have that. 2 over 5, 2/5. And then 2 over 10, that will reduce to 1/5. We already have 1/5. Next up is 3, plus and minus 3. Then next up will be 3 over 2, plus minus 3 over 5, plus minus 3 over 10. Next numerator 4. 4 over 1. 4 over 2 is 2. We already have that. 4 over 5 is new. And then 4 over 10 will reduce to 2/5. We've already got that one. Up next, 6, plus or minus 6. 6 over 2 will be 3. We already have it. 6 over 5 is a new one. And then 6 over 10, that will reduce to 3/5. That's already accounted for. And then finally, 12 over 1 is 12. 12 over 2 is 6. We've got that. 12 over 5 is new. 12 over 10 will reduce down to 6/5. That's already been accounted. So there are 32 possibilities. Where do we begin? Just start guessing and checking with synthetic division. Well, in this example, they're going to give us a graph that will be helpful. Here it is. So we look at the graph, maybe we plug it into a TI-89 or the graph's provided on a test, and we look at this. Is anything jump out at us? Well, let's see. Here's 1, and that's not crossing at 1. So that could be a fraction. It could be irrational. This one over here, it doesn't look like it's by any number that they're giving us. But this one here, that looks like, no, back. Yeah, this one here, that one's just off of, well, that would be -1 about there. So we're not sure about that one. But this one here looks like it hits right at 2. And in our list of possibilities, 2 was in there. So if we're going to say x minus 2 is a factor, we should be able to factor that and have an easier polynomial to work with. Let's synthetically divide. So we're going to divide 2 synthetically into negative 10, positive 15, positive 16, negative 12. So we're expecting a zero or a remainder here. That would be negative 20, and we add those up and get negative 5. 2 times negative 5, negative 10. That adds to 6, and it looks like the graph was helpful. Negative 12 and 12 add to 0. So what we have is this other quadratic is going to be negative 10x squared minus 5x plus 6. So the graph gave us a hint, and out of those 32 possibilities, we got right to one that worked. Now the other ones based on the graph look a little irrational. So let's do the quadratic formula on this. Our a value is negative 10, b is negative 5, c is 6. Quadratic formula says x equals negative b plus and minus the square root of b squared will be a 25 minus 4 times AC. A times C is negative 60 times 4 will be negative 240. All over 2 times A, that'll be a negative 20. So let's see, minus a negative, add the opposite. And what we have is 5 plus and minus the square root of 265 over negative 20. Now, if we punch that in the calculator, the positive root is negative 1.0639. The 5 minus the radical is positive 0.5639. And those look like they'll be backed up by the graph we used earlier. So here we go, a little less than negative 1. That one I almost thought was on negative 1. It's just to the left of it. And then here, oh no, that's a positive. Oh yeah, well I said the 5 plus, this is the 5 minus, but that's not a negative value. That's a positive 0.5 or a little bit more, and that's right there, a little more than half. Oops. Conjugate pairs. In 1C, which one was that? Oh, that was way back in the last video. Note that two complex zeros, 2 times I and negative 2 times I, are complex conjugate. That is, they're in this form, a plus b times I and a minus b times I. So this little box here says that complex zeros only occur in conjugate pairs. If there's one, there's always another. It's pair. Let f be a polynomial function that has the real coefficients. If a plus bi, where b is non-zero, so there is an imaginary piece, is a zero of the function, then the complex conjugate a minus bi is also a zero of the function. They have to come in pairs. Be sure you see this result is true only when the polynomial has a real coefficients. For example, the result applies to this function x squared plus 1, but not to the function x minus 1i. Okay, example 6. Now they're asking us to find a fourth degree polynomial or create a fourth degree polynomial, so it'll have an exponent 4 when we're done. We'll call our function f that has real coefficients and has negative 1 and negative 1 and 3 times I as zeros. So let's see, we have x equals negative 1 is a 0. X equals negative 1 is a 0. It's repeated, but we got to count for it twice. And then it says we have x equals 3i. And that last theorem says that if we have 3i, there must be a minus 3i out there also, because they only come in pairs. So let's set each of these to 0 to create our factors. We add 1, so that will be x plus 1 as a factor. The second one is the same thing. We'll add 1 to both sides, x plus 1, another factor. If we move the 3i over by subtraction, that will be an x minus 3i. And then this one will jump over and become an x plus 3i. So there's our 4 factors. Let's see, let's FOIL out. I'm going to FOIL out these two. So first times first, x squared. outers are 1x, inners are another x, so that's 2 of them. And then last times last is 1 times 1, or 1. Now we're going to multiply this by what happens when we FOIL this out. Here's why we had the warm-up. X minus 3i and x plus 3i will become x squared minus 9i squared. And that I squared is going to change this to a plus. So that'll just be x squared plus 9. Okay. Now, this is more than foiling because it's a 3-termer times a 2-termer. And I'm sort of going to work right to left. So I'm going to multiply the x squared times x squared. There's my x to the 4th. X squared times 2x is a 2x cubed. X squared times 1 is just x squared. And now we'll sort of distribute that 9. Let me switch, I guess, back to red ink. 9 times x squared is 9x squared. I'll write it right under this one. 9 times 2x is 18x. That gets its own column. 9 times 1 is 9. Now if we add these columns up, x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. There's our 4th degree polynomial. I guess we should name it f of x. That's what they wanted it. Polynomial function f with those real coefficients. So if we factor it back down, we'll get back to where we started. Good times. All right, what do we got here? Let me give you a hint on this one. First, find all your possibilities. Do your fraction, the factors of 18 divided by the factors of 2, and let me draw you a graph. Abracadabra. There's our graph. So let's say, you've got this on a test and the graph was provided to give you a push in the right direction. From the graph, you can see one of the solutions, and you can synthetically divide, and from there probably use the quadratic formula. So have fun with that one. This one is just like the other example. You've got roots of 2, or solutions of 2, negative 2, and minus 7i, and you'll come up with a 4th degree polynomial. So pause the video, work those out, and then check your solutions. Okay, for this one we could see from the graph that x equals negative 1 is a solution. So we're going to divide a negative 1 synthetically into negative 2, negative 5, 15, 18. Bring down the negative 2 and multiply, add. Multiply, add. Oops, I missed a negative there, didn't I? That would be a negative 3. And then that would be a 3. Add that up, you get an 18. There it is, negative 18, remainder 0. So we have x equals 1 as a solution. So that means x plus 1 is a factor. And then we have a negative 2, x squared minus 3x plus 18, which we should be able to do the quadratic formula on. Because based on the graph, the other solutions there will be not nice whole numbers. So let's see. A is negative 2, B is negative 3, C is 18. X equals negative B plus and minus the square root of B squared minus 4 times AC. Let's see, AC will be a negative 36. So that's a negative 4 times a negative 36. That'll turn positive. Add 9 to that. 153. 3 plus minus the square root of 153. And I did not forget my divided by 2a. 2 times a will be negative 4. I would leave my answer just like that, especially if it's on WebAssign. It will take it. You could simplify the root of 153, 3 plus or minus 3 root 17 over negative 4. And then if you get the decimals, the plus and minus, you'll get about a negative 3.8. We saw something like that on the graph, and a positive 2.3. But decimals aren't as good as leaving it in the quadratic form there. All right, now we get to make our own polynomial. So we have 2, negative 2, and negative 7i. X equals 2, x equals negative 2, x equals negative 7i. And we know that those come in conjugate pairs, so there is a plus 7i out there also. Let's make them into factors. Subtract 2 from both sides. There's a factor. Add 2 to both sides. Here, add this, so that's a plus. Oh, this is going to work out nice. And then we subtract there minus 7i. This is going to FOIL nicer than the example, but you already knew that because you did this problem before watching the solution, right? So if we FOIL this out, we'll get x squared minus 4. And that gets multiplied by here. X times x is x squared. And then we'll have a minus 49, but the I squared will turn that to a plus 49. And the foiling continues. X squared and x squared is x to the 4th. Here will be a plus 49x squared, and then a minus 4x squared in the middle. And then 4 times 49, that's the same as 4 times 50, but minus 4, so 196. Minus 196. And to make it look even nicer, we can combine these middle terms. That'll be a plus 45x squared minus 196. And there's our function. Let's call it f of x equals. There we go. Is that the last slide? Oh, no. This one, I did modify example 7 from the book to make this a little cleaner. If this is not in your notes, I can't remember if I updated the notes. If the other stuff is in there, we want to scratch it out, and we're going to do this problem. Find a cubic polynomial function f with real coefficients that has 1 and 4 and zeros. This is sort of like what we saw in the last example, but now we've got this. They give us a solution point. So what we're going to solve for here is an a value, kind of like we did when we were working on parabolas. So let's get this started. Cubic polynomial. It has x equal to 1, x equal to 4i, and of course the conjugate pair will have a minus 4i included. Let's create our factors. Subtract 1. Here we will subtract a 4i. And the last one, we add the 4i. Okay, let's save this x minus 1 for last, because if we FOIL this out, it's going to be just a nice foiling because it's a sum and a difference. First times first is x squared. When we do the 4 and the negative 4, that'll be a minus 16, but the I squared will turn that to a plus 16. Okay, there we go. X times x squared is x cubed. We will have a plus 16x, a minus 1x squared, and a minus 16. Okay, now this last piece. What we've got here is a polynomial, but there might be some, a leading coefficient in front of that x squared. And you notice I grouped this off because they gave us this point. F of 2 is 60. So if we put a 2 through this, f of 2, out should pop a 60. But remember, there might be some unknown a here. This might be like a 2x cubed or a 3x cubed. We don't know. And we have to treat that as a group. So let's plug in a 2 for all those x's. So that'll be a times 2 to the third, that's an 8, plus 2 times 16 is 32, minus 2 squared is 4, and then we got a minus 16 equals 60. So let's see what's going on inside those red parentheses. We've got a, and then I'm going to do it this way. 32 minus 16 is 16. 16 plus 8 is 24. 24 minus 4 is 20. So that's a times 20 is equal to 60. Oh, and that'll work out real nice. Divide both sides by the 20, and we get a equals 3. So if I go back up here, this a out front, we can replace that with a 3. Let me even just drag this out of there. Ooh, hold on. So a is 3. I erased my equation. There it is. There it is. So I'm going to back up to here. This a is going to be moved out of the way. And we could put a 3 there. A is 3. So now to make our final answer, our final polynomial, let's just distribute that 3. 3x cubed plus 48x's minus 3x squared minus 48. That's a beautiful polynomial. All right. This is for you to try. This will be the last the Huddle problem here. And of course, the homework will be on WebAssign. So pause the video and find this fourth degree equation that has real coefficients 1, -2, and 2i. Don't forget the conjugate pair. And here is your solution point to solve for a. Pause the video. So here's our solutions. Let's turn those into factors. We will subtract 1 here. We will add 2 to both sides there. X minus 2i is a factor, as is x plus 2i. Okay, these conjugate pairs always foil nice. Let's do those first. X times x is x squared. 2 times 2, that'll be a -4, but the I times I will change that to a +4. Okay, now this will be a 3-termer, a quadratic, x squared. The outers will be a 2x, the inners a minus 1x, so that'll be a plus x minus 2. Okay, again, I'm going to work right to left. We get black ink here. X times x squared, or x squared times x squared, x to the 4th. Here we'll have an x cubed and a minus 2x squared. Distribute the 4. That's a 4x squared. And a plus 4x. And then last times last is a minus 8. So when we add these columns, we get x to the 4th plus an x cubed plus 2x squareds are there, and a 4x and a minus 8. But remember, there could be an unknown a out front that would need distributed all over this for our solution point. There we go. Solution point, I'll hit it here in red. F of -1 is equal to 10. So that just says if I put a 1 in for all the x's, it's going to equal 10. And remember, there's some unknown a out here. So this won't be too bad. A -1 goes in. Remember, the negative will square away, or 4th power, or 6th power. Even exponents will eat that negative up. So here, this -1 to the 4th will just turn into a 1. This -1 to the 3rd, the negative will escape, so that'll be a minus 1. Here, the -1 will square away. Times 2 is 2. This -1 will change that to a minus 1. And then we just have a minus 8, and that's equal to 10. So let's see what goes on in the parenthesis. 1 minus 1 is 0. So we got 2. 2 minus 1 is 1. 1 minus 8 is, ooh, did I mess something? There it is. This was supposed to be, when this negative distributed, minus 4. I got a 1 there, but I just had to do that. Okay, that should fix it. 1 minus 1 is nothing. Plus 2 minus 4 is negative 2. Minus 8 more is negative 10 equals 10. So we divide by negative 10. A is negative 1. So if I go back up to here, I can replace this a with a negative 1 and distribute. So that'll be a negative x to the fourth minus x cubed minus 2x squared minus 4x plus 8. That's our function, and I should have named that equals f of x. Okay, again, the homework is on WebAssign.